So let's look at some examples of rationalizing the denominator. So for number 1, I have this square root of 2 on the bottom and I want to get rid of it. Well, we learned from that previous video, to get rid of it, all I need to do is multiply top and bottom by that radical, because that creates that perfect square. And so when I do that, the square root of 2 times square root of 2 is just equal to 2, as we saw, since it's really going to be square root of 4, which is equal to 2. And then on top, I need to be careful here. So I need to remember that I can only combine those, I can only multiply together those that have the radical. So that 3 is still just going to be there, but then I can do the square root of 5 times the square root of 2 to get the square root of 10. Now I need to look at that and see if I can simplify that further, and I see that I can't. The square root of 10, there aren't any perfect squares in there, since if I break it up, it's just 2 and 5, and I can't simplify 3 over 2. And so this will be my answer. Okay, now let's look at number 2. So here I have the square root of 2 over the square root of 8. Again, to get rid of that radical in the denominator, I can multiply top and bottom by the square root of 8. So square root of 2 times the square root of 8, I get the square root of 16, over the square root of 8 times the square root of 8, again, it's just going to be 8. But now I see here I can actually simplify this further. I recognize that 16 is a perfect square, and so when I take the square root of that, I get 4. That's because 4 times 4 equals 16. And then I see that I can still simplify that even further. So if I do 4 over 8, I can divide both top and bottom by 4. And so I get that this is equal to 1/2. Now I see there's actually a simpler way I could have gone about this problem. Something special with radicals is that if I have a radical on top and bottom, I can rewrite that as the square root of 2 over 8. So instead of them being separated, I could have taken the square root out. And then I could have recognized that 2 over 8 is the same thing as 1 over 4. And then I could separate those radicals out again. And so then I have a square root of 1 over the square root of 4. Well, the square root of 1 is just 1, and the square root of 4, I get 2. And so I say I get the same answer either way. However, that won't always work out, but if you happen to recognize it, then sometimes it's a little bit easier. Okay, let's do one last one. So here I need to get rid of that square root of 10 at the denominator, so I'm going to multiply top and bottom by the square root of 10. And so I have 5 times the square root of 10. Again, I can't make that 50 because 5 does not have a square root with it. It's just 5. So because of that, I would only write that as 5 square root of 10. That's as simplified as I can get. And then the square root of 10 times square root of 10, I get 10. Now looking at this, I need to see if I can simplify this further. Well, I noticed that I have 5 over 10 here. And so that fraction, 5 over 10, can be simplified. That's because 5 can divide into 10. So if I do that, 10 divided by 5, I'm left with 2. And so I get that this is equivalent to the square root of 10 over 2.